So, in this lecture, we are going to learn about the basic parameters of a Zener diode and in which region, how the Zener diode acts, and how can we use it in our advantage. So, first starting, this is the IV characteristics of the Zener diode, and we are basically interested in this region, this negative side, this reverse region. So what happens here is that I have some parameters written here, this VZK, then this VZ naught, and then here this VZ, then here this is del V, here del I, this minus IZT, and then slope is 1 by RZ. This I have actually talked about in previous lecture, and VZK, IZK. So what are all these? So firstly, as I have written here, that IZK is the knee current and VZK is the knee voltage. So what does it actually mean? So it actually means that after this IZK, after this knee current, the slope is almost the slope gets almost like it is quite high. The slope is quite high after this IZK, and the corresponding voltage is VZK. That is the knee voltage. So what is the significance? And so this VZ naught, what is it also? So the significance is that here I have drawn the circuit of the equivalent circuit of a Zener diode when the current IZ is greater than the current IZK. Means if we are far left from the point of IZK, means our current is greater than the IZK, and obviously if IZ is greater than IZK, then obviously our voltage is going to be greater than VZ naught, and VZ naught is actually a parameter which is typically very close to VZK. So typically VZK and VZ naught are almost same, and this VZ naught is actually used in this equation like this, that here in this circuit you can see that this total voltage is VZ and the voltage source replacement of the diode is VZ naught and the resistance is RZ. So VZ equals to VZ naught plus RZ IZ. IZ is the current here, which is obviously, which should be, has to be greater than IZK. So this equation is actually pretty similar to that equation of our diodes of CVD plus R model, that VD was equals to VD naught plus ID RD. So this is pretty similar to that, and here this VZ naught actually corresponds to that VD naught, and this is very close to IZ. This is very close to VZK. So, and typically they are considered almost same, and RZ is the inverse of the slope here, and for this equation to work, actually IZ has to be greater than knee current IZK. So this is very important, because when you will be given some parameters and you will be asked to check that is your Zener diode working in the breakdown region, you have to check that if your current is greater than knee current, because after knee current your Zener diode is working in the breakdown region. So the basic significance of this knee voltage and knee current is that after knee current or after knee voltage, this Zener diode works in the breakdown region, and that breakdown region is our region of interest, because at that place this VZ equals to VZ naught plus RZ IZ. This is normally like the diode that we were talking about previously, that we were using in CVD plus R model in our regulators. So this is very important, that if your Zener diode is working in breakdown region. So this is pretty important. So now if I want to show you that different regions of Zener diode, So firstly, what I said before, that this is actually the configuration of the Zener diode, the symbol, and it is in the reverse region. When we are, it is in the reverse region when we are using it as a regulator. So first of all, how to define these regions that I am talking about, this breakdown region, and also how and when these regions are operating and how to use these. So first of all, if our current Iz, this Zener current Iz, is less than Izk, means this is, if Izk is here and if our current is less than Izk, means I lies in this small region, So if this lies here, so you can see that for this current, for this levels of currents, so there is actually this is actually open circuit, because after that, after knee current, it goes into this breakdown region, and before that the voltage is actually, before that the if Iz is less than Izk, so before that it actually acts as open circuit. So that's a condition, that if your current, Zener current, is less than knee current, then your Zener diode will be working as open circuit. So it is pretty important to remember. Now our most favorite region of Zener diodes is the breakdown region. And as I was talking about here previously, that if your current is greater than knee current, then it is in the breakdown region, and at that region it works like this circuit, and as I have drawn it here before, so it is in the breakdown region. And what happens if your Iz, look at the direction of Iz. The direction of Iz is that the Iz is entering the cathode and then it's leaving the anode. So if Iz is less than 0, what does it actually mean? If Iz is less than 0, it actually means that the direction of the current is actually now reversed. It means if Iz, this in this direction, it is negative, it means that its direction has reversed. It means that now it is going through the anode and then it's leaving the cathode. It means that it is in its forward biased region, because we know that if you have a diode, this is the anode and this is the cathode, and if your current is passing through the anode like this, you know that your diode is in the forward bias region. And in that case, it works just like a normal diode. It will have its RD that I have shown you previously here, this RD, and then it will have this VD naught, not VZ naught, or this will have VD naught and RD naught, not VZ naught and RZ, because that is its parameters. Those are its parameters in breakdown region. So to summarize, you have three regions of a Zener diode. You have three operating regions. It can work as open circuit if your current is less than knee current, but obviously if your current is greater than 0 and less than knee current, then it is open circuit. But if your current is greater than knee current, then it is in the breakdown region, and if your current is less than 0, then it is operating in forward bias region. So that's all for this lecture. Next we're going to show you an example and how to solve problems related to Zener diodes.